Hi class, today we'll talk about infinite geometric series and our objective is to be able to find these sums. Let's get you started. So there are two different series that we will discuss. You have the series that converges and the series that diverges. Let's have a discussion about the series that converges. In order to say that a series converges, we need to establish finding the absolute value of the ratio. Okay, in this case, we need to check if the absolute value of the ratio is less than 1. Let's take a look at this example on the left-hand side. I have the series given on top with a table that shows a partial sum and a visual. Let's start with a ratio. Let's take 1/4 and divide it by 1/2. When we simplify this, you can do this on your calculator if you prefer, but manually you take 1/4 and multiply it by the reciprocal of the denominator. In this case, we end up with 1/2. And obviously we know 1/2 is less than 1. So we say, okay, well, I guess this series right here is actually a series that converges. All right, now that doesn't really tell us much. We still need to identify what that means to us. Okay, so we say a series converges if the absolute value of the ratio is less than 1, but it also means that we need to look at the pattern of the partial sums. Let's move on to this table right here. When you talk about partial sums, you have this row right here where n represents the number of terms being added, and S sub n representing the partial sums. Okay, so if we were to add two terms together, the first two terms, we end up with 3/4. If we were to add the first three terms, 4 terms, and so on and so forth. And as a visual, we take a look at these points right now, where the x-axis right here represents your n, or the number of terms being added together, and the y-axis will represent the value that the partial sum is approaching. All right, let's take a look at these points. If we were to add the two terms, the first two terms, we end up with this point at 3/4. The next, or the first three terms, right here at this point, and so on and so forth. Notice how if we connected those points with a nice smooth curve, notice how it's approaching a specific value. In this case, it appears that our sets of points are approaching this line right here. This is what you will call your limit. Let's label it. It's the limit of the partial sum. It's the most it can reach, but not really touch it. Okay, so we talk about this value, and it appears to be 1. So we say this series is a series that converges, and it approaches the value y equals 1. Okay, similarly, if we now move on to the series that diverges, we look at the common ratio. In this case, the absolute value of that ratio must be greater than or equal to 1. All right, let's observe this second example, R sub n. Let's take 1/16 over 132. All right, and let's go ahead and simplify and find our ratio. I'll take the numerator, multiply it by the reciprocal of your denominator. Thus, we end up with a 2. Again, we know it diverges because this value we found, its absolute value, is still greater than or equal to 1. If in the past we looked at the partial sum approaching a specific value, when you talk about a series that diverges, it does not appear to be approaching any specific value. So let's take a look at a visual right here. If these points represent the partial sums based on the specific number of terms being added together, notice how it just continues increasing. It doesn't really approach a specific value. So this is a really good visual of what a series that diverges would look like. Okay, let's start looking at a few examples. Let's determine whether the given series shows a series that converges or diverges. Let's start by identifying your ratio. Okay, so let's take a look at this. In this case, I'm using 24 and 20, and if I simplify it, I'll end up with a 1.2. Now remember, when you're looking for the absolute value of a ratio, okay, you need to determine if it is less than 1 or greater than or equal to 1. In this case, it is definitely greater than or equal than 1, so we say that the series actually, right, diverges. Okay, just like that, you can tell whether a series converges or diverges. Or we also note that this series does not really approach a specific value when you try to look for the partial sum. Let's look for another example right here. Okay, once again, start with the ratio. Okay, you must determine if it is less than 1 or greater than or equal to 1. Let's use 1/3 and divide it by 1. So in just the same manner, I would go ahead and end up with a 1/3 or a 0.33 rounded if you prefer. And so we say the absolute value of this ratio is less than 1. Therefore, the series, okay, this time converges. And just like that, you can determine whether your series converges or diverges. Let's take a look at 2 more examples for you to try out. Feel free to pause the video at this point. Give yourself some time to identify the ratio and determine whether each of these are converging, or series that converge, or series that diverge. In this case, we found our ratio for the first one to be equal to 3/2. And because of that, we say that this series actually diverges. On the other hand, the ratio for the second one is actually 1/2. And we say that this series converges. Okay, I hope you paused the video and gave yourself some time to check this out. Let's move on to another example. In this example, we are now going to move on and look for the sum of an infinite geometric series, okay, denoted by this formula right here, where S represents the sum whose common ratio R, okay, well, of course, because we're looking for a specific sum, the ratio, the absolute value of that ratio must be less than 1. And a sub 1 is still your first term. Let's take a look at this example. Given the series, we are instructed to find the sum of the infinite geometric series. Let's take a look at this. We need to identify a sub 1. That's the first term you have. And now let's try working on finding the ratio. To find the ratio, you repeat the same steps. Let me use 4 and divide it by 5. In this example, I found that the ratio is 0.8, where the absolute value of our ratio is less than 1. If so, let's go ahead and plug in the information we have into your formula. All right, partial sum of the given series is when we plug in 5 for the first term, and we plug in 1 minus 0.8. And when you simplify this, right, make sure you use a parentheses if you're doing this manually on your calculator. Otherwise, please make sure you're using the fraction option so you don't miss any value. All right, so I found that the sum of this given series, the partial sum, would be 25. What does this represent, right? Okay, we know the ratio. It tells us if the series converges or diverges. But now we found this sum. What does it really represent? What this really tells you is that on the graph, right? Do you remember the graph at the beginning? Okay. The graph will approach 25 right here. So you say this 25 actually represents the partial sum, or the fixed value that the partial sum is approaching. Okay, so let's take a look at the next example. Let's look at this other example where you're working with a sigma notation. So just like the same thing we've done in the previous example, you look for the first term, you identify the ratio as well. Let's get you started. So right now I'm going to go ahead and work on finding the first term. So to find the first term, we plug in k equal to 1, so you go 2 over k, or 3 to the k, which is 1 minus 1. Then we simplify this as 2 over 3 to the 0. Anything raised to 0 is a 1, so we really end up with the first term being a 2. If so, let's go ahead and find another term to help us identify the ratio. All right, so now let's plug in 2 for k. So I'll go 2 minus 1 here, or 2 over 3, which would be the second term. And so to identify the ratio, we divide 2/3 by 2. So we say, take the numerator and multiply it by the reciprocal of the denominator, thus giving us a ratio of 1/3. We now have the information we need, the first term and the ratio. Let's plug it in to find the sum of the infinite geometric series. So we go ahead and plug in 2 over 1 minus 1/3. And so it appears that the sum is actually 3. So we say that the sum of the series, this infinite geometric series, seems to be approaching 3. Let's now give you some opportunities to try working on the next 2 problems. Feel free to pause the video at this time so you can work on finding the sum for the given series. It appears that for the first one, we will produce a ratio of -1/5. Okay, we know the first term. And so upon plugging everything in, we seem to find the sum of an infinite geometric series right here is actually going to be 125 over 6, or if you prefer using decimals, about 20.83. In the same manner, okay, in the second example, because you are using a sigma notation, you need to identify the first term. It appears that our first term is 2/5. In this case, I used the second term, and I found it to be 4 over 25, where eventually it led me to the conclusion that my ratio is 2/5, which is exactly this explicit rule is showing us right now. Okay, all right, so if that were the case, I did check that my sum is actually about 2/3, or if you rounded, about 0.67, if that's the case. All right, so let's bring it forward. The next part of this lesson is helping you write repeating decimals as fractions. There are only 3 steps you really need to take. First of all is to write the repeating decimal as an infinite geometric series, and then find the common ratio, and eventually lead up to finding the sum. So let's take a look at this example where we need to write 0.2323 repeating as a fraction in simplest form. So let's follow the 3 steps. First, it says that we should write a repeating decimal as an infinite series. How would that look like? This is where your place values really come into play. I know it's been too long, but it really helps to remember. So in step 1, all right, let's write the given repeating decimal as a sum. What that would look like is this. Because it's repeating by 0.23, okay, and so if we already have your tenths and hundreds, or tenths and hundredths, I should say, we leave them as 0 now, because now you're plugging in 23 for the remaining values. Right now, this is what you're looking at. That's why we left these 2 positions as 0, because we already used them. Plus, all right, let's continue. This time we have 4 zeros and a 23, and so on and so forth. Okay, part 2, or step 2. Let's find the common ratio. So if you were to use the first 2 terms, this eventually leads us to identify our ratio to be 0.01. All right, so we follow the steps to write it as a series and find the ratio, and now we're ready to plug in the information we have to find the sum. So let's do the first term up on the numerator, 0.23 over 1 minus 0.01, our ratio. Okay, so this is the part where you should not leave your answer as a decimal. Remember, we're trying to write your answer as a fraction in simplest form. So here's what I would like you to do. The numerator will remain as 0.23, while your denominator, when simplified, is going to be 0.99. okay? And if you are really just simplifying, this is really just telling us, well, the fraction 0.23 repeating is really just 23 over 99 as a fraction in simplest form. So let's give you the opportunity to try out these 3 steps. On our next example, you can pause the video for a while and try looking for the sum, and then check your answer afterwards. Let me go through the steps right here. In step 1, we are instructed to once again list this down as the sum of an infinite series. So I will put zeros as placeholders for the first 2 positions and continue on. All right, so as you can see, we are completing step 1. Step 2, let's find your common ratio. I would go ahead and use the first 2 terms. All right, it appears that our ratio remains to be 0.01. If that's the case, we are ready to plug in our information. I'm plugging in our first term in the numerator, and in the denominator, I'm going to plug in the ratio that we found. It appears that our numerator remains 0.13, right? While our denominator is 0.99. And so if we were to simplify, leave this in the simplest form, the repeating decimal 0.13 is actually 13 over 99 as a fraction in simplest form. So hopefully we are explaining and answering questions you may have in mind about the geometric series. Bye for now.